Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Right, so I'm going to go through the question paper that I provided. That I've written for the 2396 mock exam. It's the real assessment, and I actually gave a link to download it on the description of the previous video in Outcome 6. Instead of just giving answers as I would give them, what I'm doing really is I'm mainly going to highlight the points of reference that we should look at to get the idea of what the question is aimed at. So, just a quick reminder then. So, 10 questions. There's the question paper if you wanted to look at it before we go through this. They're 10 questions, but they are 10 blown up questions, and you have 3 hours to do it. And remember, this is an open book assessment, so it's not so much about your ability to memorize; it's about your ability to reference and use the documentation that's there. So, when I did this, I did this previously. The last one I did was 239120. I used the full 3 hours, and I literally filled the paper up. But mostly just because I was just waffling a little bit, but I got a distinction on it. But what I want to do is, instead of showing you my blown up written answers, because I can probably sometimes overdo that, I'm just going to show you where the reference is. That's the best thing. Okay. So the very first question we had was this. Number 1. A new build 5-bedroom house connected to the distributor's 230-volt single-phase supply, formed part of a TNCS system. A metal-framed and clad workshop, that's an important point, will be located in the garden. Describe the requirements for both the building regulations and BS 7671 that is relevant to design considerations for each. As you can see, it's mentioning here building regulations and BS 7671, so we need to be able to reference both. Now, as I've said throughout the 2396 series, it's important to have done regulations training or to have a good understanding on reference of the wiring regulations. Similarly with the building regulations. Now, I'm not going to say you have to do a course on that. Most definitely don't do a Part P course. Best case would be the 2393 City and Guild course. But if you download the free approved documents, A through to A, B, C, E, L, M, and P, it's probably all the ones you need really. This criteria is in those. So familiarise yourself in any way that you want. But if you want to spend a bit of money, just get the building regulations book. Can't really complain with that. And you'll notice I'm not using the 18th edition content. I have the 18th edition content, but I'm not using it. This is staying honest to the current version, the current standard. I won't be using 18th edition until it comes in next month. So, we've got to look into the installation of the extra low voltage downlighters in zones 1 and 2 of both bathrooms, the methods of providing electrical protection for buried cables in the walls, one method of providing a means of earth into the workshop, and that's interesting because remember it's a metal framed workshop. Maximum and minimum mounting heights of switches and sockets respectively, and the number of low energy lighting outlets and installed relative to the general purpose lighting of the installation. Some of these questions are directed to the wiring regs, some of these questions are directed to the building regs, some of these questions have a little bit from both. Okay, so I'm going to use both documents really as I go through this one. ELV downlights in zones 1 and 2 of both bathrooms. I'm going to stick with the wiring regulations for this one because it's mainly wanting me to point out that we need to think of there. We've got in zones 1 and 2 luminaires, and it also tells us, if I can get my PowerPoint to work. There we go. It also tells us that the required external influences for zones 1 and 2 is IPX4. Okay, so that's what we get for that. Okay, there's no requirement of itself specifically here. It's not that. It's just about the requirement for the installation of extra low voltage lighting. Now you could also go down the line of, fire barrier, fire stopping, making sure the lights are fire rated, but there's not really enough in the scenario to actually explain that the lights are going to be installed in a fire barrier. Yes, it's a home. Yes, it's going to be lights in the bathroom, but it doesn't really want to go down that avenue. It just kind of wants you to kind of find information in BS 767 ready for this one. Now, 2 methods of providing electrical protection for buried cables in the wall. Well, we have 526.202, which gives us the zonal directions, and also gives us a requirement of .6.204, which gives us the conduit, metallic covering, earth trunking, selve or pelv. So those are the protective requirements of BS 7671. There is an illustration of this section, the zonal concept, in the building regulations document here. So each of these documents would help in this case. Alright, so the question was 2 methods of providing electrical protection for buried cables in the walls. So again, electrical protection, you probably want to look at things like protecting against mechanical damage or RCDs and things like that. One method of providing a means of earthing for the workshop. The key thing with this is the metal framed clad workshop, meaning that the workshop is of a metal frame, so the workshop technically has become an extraneous conductive part because it's in contact with the earth. So the question of does it need to be bonded is yes. Now, in the wiring regulations, there's not going to be much that's specific for workshops, but if you go into the building regulations book and you actually look up the subject of sheds, for example, it will actually send you to this section for supplies of outbuildings, and it'll tell you, if it's an external PME supply and they're exposed conductive parts, we either have to take our protective bonding to the exposed conductive part, or separately actually make a TT system within the actual shed. Again, this is considered as an exposed conductive part, so there is a need of reference. So that's the information there for that one. So you could pretty much just go through either of these two options as an answer to that one. Maximum minimum mounting heights of switches and socket outlets respectively. Now, first of all, you immediately think of approved document M. So you go to the building regulations again with this one. Heights of switches and sockets, and we have the lines there. So that's it, maximum minimum, that's it. Okay. That would be it. That would be enough. I would go a little bit extra because I'd be thinking of BS 7671 as well. What relevance has BS 7671 got to this question? So I would be saying is, well, there's no given height, but the height must be sufficient to avoid damage. And so I'd also just mention 553.1.6. Okay. So whilst these are the heights that are given, it could be that if we still go to these heights, that there could be a risk of mechanical damage to the socket outlet. So it's worth adding that as a little bonus point to that question. Okay, the number of low energy lighting outlets to be installed relative to the general purpose lighting installation. This is obviously, you think about it, the wiring regulations doesn't cover anywhere like this with energy efficiency or anything like that yet. But what we're going to have is proof document L. Or again, if you go to the building regulations book, you've got fixed internal, fixed external lighting. And the question was the number of low energy lighting outlets relative to the general. That's pretty much this bit here. Okay, so 3/4, not less than 3/4, so 3 out of 4 of the main dwelling spaces. So the main habitational areas, corridors, bedrooms, living rooms. Yeah, don't make, for example, your 3 out of 4 being lighting in a plinth or lighting in a wardrobe. It needs to be an actual formal luminaire within the home. And so 3 out of 4. It used to be a lot less. It used to be like 1 in 4, I think, or so 10 years ago. So they've increased that, and that makes sense with the way things are going. But that's it. That's more than adequate to answer that one. So, question 1 was asking about your understanding to go from wine regs to burner regs. This one, you'll notice, is actually just really wine regs. Caravan park has a provision for the connection of a 230-volt single-phase supply to a touring caravan sited within the park. Describe how such supplies may be installed in order to comply with the regulations related to each of the following. So, special installation, special location. We need to go into BS 7671, and we need to find 708 caravan parks. So if we go through them, how such supplies may be installed in order to comply with BS 767 related to each of the following. The type of wiring system and method of installation. Well, in 708 there will be wiring systems in caravan parks. It should be underground or overhead, and underground is the preferred one. Types of protected device. Yeah. Individual overcurrent protected device in accordance with chapter 43. Okay, and have individual RCD protection. Location and purpose of the notice. I'm going to skip that one. Okay. Identify the earthing system that may not be used to supply the caravan. That's also in 708. Yeah, it's a TNCS system, the PME. Again, this information should be pretty much second nature at this point. If you're unaware of that, and you really want to go to the regs to just confirm, or maybe find the regulation number for reference in your written answer. If you're unaware of that, then yeah, you need to look at your understanding the regulations before you pursue a design course. Really, okay. I skipped the third one, the location and purpose of the notice to be fixed, and that's because it's actually not in 708. It's in the caravans special installation location section 721. So the instructions will be provided, and it can be used safely, and it gives you the information there of the instruction and an example of it. B. The type of rating of the socket outlets to be installed for the pitch supplies and the mounting height given the possibility of flooding or heavy snowfall. Back to 708. It tells us that it'll have to be a 60392 IP44. Okay. It tells us the height. Yeah. 0.5 metre to 1.5. With flooding or heavy snowfall, then we go over 1.5. And the rating of 16 amps. So all the information's in there. You know, fairly quick to find, really. 3. Is that the last one? Yep, okay. 3. 400 volt 3-phase motor operates at full load with the input of 10 kilowatt at 0.8 power factor. Supplied from a distribution board by 3-core steel wire armor, 90-degree thermosetting cable, copper. And it's a single circuit clip direct on a BS-88 fuse, 20 meters of run, 35-degree ambient with a maximum volt drop of 5 volts, and calculates some stuff. Okay, so this is obviously, you can see how this is a different area of the design, and this is where you may have to actually get your calculators out. I did do a video in the 2396 series on cable calculations, which would help with this. It was a single phase. This is 3 phase. There's only a minor difference with that, and we'll start with that. So we're going to follow the same principle though that I showed you in that other video. So we're going to go IB, IN, IT, CA, CI, IZ, and then volt drop. We're going to go in that flow. Alright. So, first thing is the IB. Determine the design current. Now with 3 phase, we obviously do, instead of P over V, it's P over the square root of 3 times 400, which is because of the 3 phases, times power factor. Okay. Power factor 0.8. We'll throw that in here. So you can run it in a number of ways. You could do this as 1.73, which is the square root of 3, times 400 times that. You can do it whichever way that you want. But we end up here with 18.04 amp. That's our design current. I don't have much information on the actual characteristics of this load. I know there's a 0.8 power factor, so it'll have some inductive component. But knowing the BS-88 fuse's characteristics, I think it's safe with an 18 amp device to go to a 20 amp fuse. I could have gone higher, but really for this I would probably state 20 amp, and I might add a note to say that it's considered that this protected device is suitable for this inductive component. But depending on obviously the operation of the motor, this is a problem. It gives you limited information here. Okay. So we're going to go with IB of 1804, IN of 20 amp. Now, yeah, remember this coordination here, IB, IN, IZ. State the correct table and columns used in BS767 for the current rating of the voltage drop. So what I need to do is obviously go to Appendix 4 and find the right cable type, and the information is here for me. So I know it's an armoured cable. I know it's 90-degree thermo setting. I know it's copper. So with that information, I can come here and I can go, right, multi-core, armoured, 90-degree thermo setting, copper. Okay. The clip direct is also required for me because that gives me the reference method. So it's there, surface clip direct. So I go to the surface clip direct, and it's a 3-phase circuit. So I'm going to go for column 3. Now I've got 20 amp, so I want the first one above 20 amp. Well, there we go, 1.5 mil 23. So I'm going to start with that. Okay, I'm going to start with that when I actually look at my cable. But before I go to that, I may need to adjust the 20. So the correction factors for the ambient temperature. Where's the ambient temperature? There, 35 degrees. Okay, so we'll get that in there. 90-degree thermo setting, 35, 0.96. We're going to apply that in the formula. That'll actually change 20, but not by a lot. So there's 0.6. So it's actually, that is IN over CA. Okay, the reason I've gone with IN and not IB is because the load may overload some motor. Okay, normally you may see IB used in this formula, sometimes. That's if your load is a fixed load, like a heater. But it's a motor, it can overload, so overload protection will be required. So I'm going to go with the IN of 20 over the CA rating factor of 0.96. Doesn't have a great impact, does it? 20.83. So I'm still looking at 23 amp, 1.5. Good. But what I need to verify is the volt drop. Alright, so there's my cable type. What I need to do though is verify this volt drop. Now it does say up here the volt drop can't exceed 5 volts. So what I know about the regulations with the 11.5 volt maximum, that's irrelevant. The equipment has specifically mentioned that we can't go over 5 volts. So I need to adjust this, possibly. So I need to calculate this. Well, table 4E4A has adjacent to it table 4E4B. There. Okay, again, 3 or 4 core cable, 3 phase, column 4, 1.5, 27 millivolts per amp, 18.04, per meter, 20 meters. Okay, 27 times design current 18.04 times length 20 meters over 1,000, go from millivolts to volts, equals 9.7 equals problem. Okay, well, that's no good. So what I need to do is go to the next one, the next cable up. So I'm going to redo that. I'm going to change 27 to 16. Okay, so that's now technically using a 2.5mm 16, and we're still knackered, no good. Alright, well, okay, go up again, got a 4mm 10, we'll chop that out, we'll put the 4mm in, there we go. So actually this 1.5 we're going to have to change to 4mm, and that will be our actual volt drop calculation. So that's kind of done the other question at the same time. You'll see here, calculate the actual volt drop. There we go, we've done that, and we've swapped the cable to a 4mm. Cable size is a 4mm because of the volt drop problem. That's that question done. Boom, 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 boom. Yep, done. 4. You're about to carry out an electrical design for the installation to a new swimming pool being added to an existing sport leisure complex. State 3 reasons why a sport leisure complex may be designed as a special location. You shouldn't even need to think of the regs book for this. Yes, it's a reg specific question, but you should think, right, a sport leisure complex, it's going to have swimming pools, it's going to have showers, it's going to have saunas. Yeah? Simple. So just boom, 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 write those down. Like that. B. Identify the requirements of BS 767 when underwater luminaires are to be installed in Zone 0. Well, we know swimming pools is 702, so if we go to 702, there may just be a section underwater luminaires. Like that. Oh, okay. So, underwater lighting located behind water. Yep, that's it. We'll take our answer from that. Oh, right. C. State the limitations that are placed upon the installation of lighting equipment in Zone 1 of the swimming pool. Okay, so lighting that's in Zone 1, what's the limitations? Alright, so we think about the requirements for that, and we'll see this section in 702. The special requirements for the installation of equipment in Zone 1 of swimming pools. And there's a lot of information, but is there anything that's relevant to just lighting? Here. Okay, so this is equipment, but this is lighting. So swimming pools where there is no Zone 2, so just a Zone 0 and 1, lighting equipment supplied by other than cell of source 12 volts. So the lighting can be of cell of 12 volts. If it's not of cell of 12 volts, then maybe installed in Zone 1 on a wall or ceiling, provided that. And here's your answer. So, cell of 12 volts, or the circuit is protected by ADS to 415.1.1, which is the 30 mA times 5i delta N, or the height from the floor is at least 2 meters above the lower limit of Zone 1. Okay. In addition, every luminaire will have to be of Class 2. So these are the special considerations. Right. D. State the purpose of the warning notices to the user of the electrical equipment that is to be used in Zone 0 of a pool, and identify the protective measures to be taken prior to using the equipment stated in D. Okay, so when we look at equipment in Zone 0 of a pool, okay, in Zone 0 and 1, we'll see here, equipment for use in Zone 0 must be protected by CELV, ADS to 415.1 RCD, and electrical separation. Okay, but the important part here is notice this. It says, which is only intended to be used when people are not in the pools. This is like pool cleaning equipment and stuff like that. Alright, so those are the protective provisions, but there should be a mention of a notice here, and you'll see it right at the bottom. The socket outlet that is supplying it must have a notice to warn the user that this shall only be used if there's no one in the pool. Alright, so that's the point of the notice, to warn the users when they actually use that socket that there should be no one in the pool. 5. Heavy goods vehicle compound has an adjacent workshop provision, together with a high pressure washing valeting facility for the lorries. Explain the designation criteria in relation to each of the following. So designation criteria, so that's, what will affect what do we think of when we're going to start selecting equipment and selecting wiring systems. So with access to road lighting and security lighting, I've kind of done them together, and with services in the workshop area and the wash area, I've kind of done them together. So with access road lighting, we'll remember that there is a requirement in the regulations of 6 meters for overhead cabling if there's any vehicular movement taking place in areas that have vehicle movement, if you're going to use that. But really, we're looking at lighting levels, motion sensors, etc. For all outdoor lighting installations to 714 in general, though, we need to make sure that we understand the requirements that they expect external influence categories to be AA2 to AA4. That's supposed to be I can't type. Climate conditions AB2 and AB4. Okay, so this is the kind of data we need to make sure we verify. AD3, which is sprays, and it actually does say in 714 that the equipment must be of IP33 minimum. Alright, so those are the specs we're looking for outdoor lighting. With regards to security, though, you do mention we also need to think about methods of operation, switching. With security lighting, you don't want the lighting to be constantly on. You need it to be on a sensor, but it doesn't need to. You don't want to create things like glare. This is where your knowledge of things like BS5266 would really be helpful as well. Okay. With the workshop area, again, you know, I'm not going to go through it all, but, you know, what kind of wiring system are you going to do? I mean, think about the risks of impact, think about the risks of moisture ingress, think about the protective measures. So, you know, you're not going to go with white plastics, you're going to go with steel containment, steel armor cabling. And there's mention of valeting, so you're going to have high pressure jets, which, I mean, I normally go down the avenue of IP69K for things like vehicle cleaning processes, but that's not actually in BS 7671 yet. So you'd stick with IPX5 for now. That's a very simple question. It's more about your, you know, what criteria you would use to make decisions on it. 6. Why is discrimination necessary? State the relationship between short circuit capacity and protective device and the prospective short circuit current. Question on a final ring circuit. And verify the values of ZS. So let's go through these one at a time. So discrimination. I've typed this response because it was just easier than trying to find anything. But I've put that discrimination is required to ensure that the isolated device only removes the source of energy from the part of the electrical installation affected by the fault condition and does not isolate other parts of the installation. This ensures safety critical equipment, data sensitive equipment, and also simple utilization of the electrical installation is not necessarily impacted from electrical faults. You can write that in your own way. But you know what discrimination is. It's making sure the isolation occurs to the point of fault and doesn't affect other areas. Other things aren't impacting it. You'll get big issues with things like RCDs and discrimination. Think about that, you know. But bear in mind, don't mention RCDs in your answer because the question is about overcurrent protection devices. If you go, oh, if I have an RCD at 30 milliamp and then I have another RCD at 30 milliamp and I don't put in a time delay, that's kind of going to take you off of the direction, because really you're talking about overcurrent protection. Okay. B. Relationship between the short circuit capacity of the protected device and the protective short circuit current at the point it is installed. I've just typed this out because I was running late, but there is text in the on-site guide, and I think it may be in Guidance Notes 3, about the braking capacities of the protected devices. The IN and IS, I think they call it, for stable and not in service, etc., etc. But again, if you've got a good understanding on inspection and testing, which you should really have as well, this shouldn't be a problem. So this is my response. I put the short circuit capacity of the protected device is the limiting amount of current that the device can tolerate during a fault condition and can be expected to remain operational upon resetting it. If the short circuit capacity is exceeded, then the device is anticipated to operate but then fail to reset. So if we go over the short circuit capacity, I call it braking capacity, but this is what they've used in these questions these days. So it'll fail to close. The prospective short circuit current at the point of the device is installed. It's a measurement or calculation to determine the value of current that will occur at that particular point in the electrical installation in fault conditions between live conductors and between live conductors and earth. Now it does say prospective short circuit current, but I've included my answer between live conductors and earth because obviously I'm thinking of the prospective fault current. If you want to be anal about the question, saying prospective short circuit current, then you would scratch that out of your response and you just say prospective short circuit current. You wouldn't mention prospective earth fault current in that. Okay. The prospective fault current must not exceed the prospective device's short circuit capacity. It might just be, I mean, this should be a common knowledge thing. It might just be that your ability to write that response needs kind of practice on it. So otherwise, that should be fairly simple. Now this one, I've deliberately put something in here because when I did the exam, I had this problem, so I've added it here. So the question is, a final circuit supplies a fixed appliance and is wired in a 6mm multi-core centrifuge thermoplastic non-armored cable, copper conductors, having a CPC of 2.5. It's on a 32 amp GG fuse to BS88-2, and the value of ZD is 0.35, and the length of the run is 40 meters. Calculate the value of ZS. So, bear in mind there's no ambient temperature given. What I've not been able to do is verify if I need to adjust the resistance values of R1 plus R2. This is what you need to do, is you need to calculate the R1 plus R2 to determine what the ZS is. Okay. Now it says here final circuit to a fixed appliance. Okay, so it's not a ring final or anything like that. It's just a single radial circuit. So to find ZS, we need to know that ZS is equal to ZE plus R1 plus R2. We have ZE, we need to find R1 plus R2. For that, we need to know what the size of the line conductor is and the size of the protective conductor is. Well, that's there in the question. And we need to know where to find that information. And if you go to Guidance Notes 3 or the on-site guide, you'll find this table. This is in Guidance Notes 3, table B1. I think in the on-site guide it's Appendix I, maybe H, I, J. I think try I. Same table. Alright. In this you'll see, okay, well, the 6mm conductor, this is why I say that these values are given at 20 degrees. Now if I'm installed in my cable and I'm running at 25 degrees or 30 degrees, there are under this table factors of adjustment. I've not given an ambient temperature, so I'm going to go with these by default. I had this exact scenario in a question in my old design course, and I didn't have a temperature. And so when I wrote my answer out, I actually mentioned as a little asterisk at the top, I mentioned that there's no ambient temperature given, and so no adjustment for ambient temperature could be made. So assuming 20 degrees, because that's what this data is given at. So 6mm on its own, 3.08 milliohms per meter. 2.5 on its own, 7.41 milliohms per meter. Well, R1 R2 is them together, so 3.08 plus 7.41, that's R1 plus R2, times the length of 40 meters, 0.42. So my R1 plus R2 of the circuit is 0.42. Now that I know that, there's those two highlighted there. Now that I know that, I can then add that 0.42 to the ZE of 0.35 to get my ZS of 0.77. Okay, that's my value of ZS, 0.77. The full current, that's just Ohm's law, isn't it? So the full current is UO over ZS. So 230 over 0.77 is 299 amp. That's fairly simple, isn't it? Alright. Verify the value of ZS obtained and C complies with BS7671. Well, I have my 0.77 ZS. I then go to BS7671. I find that my 32 amp GG fuse here, bear in mind, as it was a final circuit, I'm going for the 0.4 second disconnection table. Okay. Final circuit. That's why I've gone to this table. So I go, okay, well, BS88 2, 32 amp, 0.99, maximum, 0.77. Yeah, it's good. So, fine. Okay, 7. BS7671 requires switchgear to confirm the requirements for isolation switching, be it functional, emergency, mechanical maintenance, etc. Control and protection against overload and short circuit current. The figure below shows the equipment for operating a group of conveyors. State using the reference to the numbers given the functional functions performed by each of the items of equipment with reference to isolation, switching, control and protection. So I think it's in is it 537 or somewhere in 53. There's a big table which tells you, all these different device types, and it then says, there are columns for emergency switching and isolation, and there's yeses and nos and things like that. And this is what this is trying to determine. It's saying, okay, you've got a big isolation switch, but what is that a method of switching for? Is it switching for emergency operation, or is it switching for mechanical maintenance, or just switching for isolation, or does it serve a multiple function? And that's kind of what this is going with. So in the case of the, here's the consumer unit. So this primary isolator is really a isolation switch, but it'll be a switch that has an indicator of off and on. And you'll know if you look in the regulations that can also be utilised as a method of switching for mechanical maintenance. It won't be used for mechanical maintenance because it's not really switching off a conveyor, but it technically is recognised as a switch for mechanical maintenance. Okay. Now, in the board, the protected devices will provide isolation. They are also accepted as a functional switch. If you actually look in the table, a BSCN 60898 MCB is ticked as functional. So technically, okay, it could be used for functional switching and protection. Okay, and then you've got 3 here. So we have mechanical maintenance and isolation, and then we have protection within the actual control assembly, and then control. And then we have this remote stop, which will be an emergency switch, which also carries isolation because it removes the source of energy. And then in here we'll have again isolation and mechanical maintenance. Okay, that's what it's asking you to recognise the type of switching that is required. The idea here is what we want to do is make sure that if I'm going to have a board that feeds a control panel, that I know that there has to be a source of isolation. It doesn't necessarily have to be a source of emergency switching that can be installed remotely. Yeah. Otherwise, if we get our switching types wrong, then it might create an unsafe condition. The second question was, in addition to these requirements mentioned, they state a further function required for the contactor starter. Well, contactor starter for motors, 3-phase, etc. Under voltage protection. Yeah, they also provide under voltage protection. 8. An earth electrode is used in conjunction with an RCD protecting a TT installation. An earth full loop impedance test may be used to obtain the resistance of the earth electrode. Describe the procedure. Okay, so you may immediately be thinking, oh, it's an electrode, oh, it's an earth electrode resistance tester, but no, read the question. It's actually saying, no. You're on an RC supply, no, you have a TT supply with an RCD present. That means we can use a loop impedance tester. So, how are you going to do that? Again, I could go through all that, but it's here in Guidance Notes 3. Okay, test method E, measurement using an earth full loop impedance tester. Switch it off before, disconnect the earthing conductor, remove the parallels. Okay, so the instructions are there. Having obtained the value of earth electrode resistance by the method stated, describe the necessary actions of each of the following. Provide a value of satisfactory for the method of earth fault protection. So there's the information here that is required. Yeah, so the main thing here is to verify that the voltage is less than 50 volts. Similarly, if you're going to use, like with an RCD, we let's say it's a 300 milliamp RCD. I think it's like 167 ohms. If it's a 30 milliamp, it's 1667. So, you know, that's all about making sure 50 volts isn't exceeded. So you can work that out. And what you should do if it's unsatisfactory, so what the actions are. All right. So that's all in there for that one. 9. Figure 2 below shows a ring final circuit in 2.5 multi-core thermoplastic non-armoured cable with a 1.5mm CPC. Okay. Method requires measurements at each socket outlet, and the resistance per meter for the 2.5mm copper conductor is 0.0074 ohms, and for the 1.5 is 0.012 ohms at normal operating temperature. Calculate each of the following. So the line and neutral at each socket, and the R1, R2 for the ring. So that's also at each socket. Alright, remember the R1, R2 will be the same everywhere. So, you know, a bit tricky. They suggest it's a different thing. It's R1, Rn, it's R1, R2. It does say here, per meter for the copper. Okay? So, what we need to do is go, oh, okay, well, that's per meter, and it's where's the length? Oh, there's the length in the drawing. 3 and 5 and 2 and 10 and 9 and 6 and 3 and 2. 3, 10, 29, 35, 50, 40. Yeah, so we have a 40 meter run. Times that by 40 to give you the value of R1 and the value of Rn. Times that by 40 to give the value of R2, and then calculate R1, Rn and R1, R2. Okay, so R1, Rn is little r1 plus little rn over 4. So R1 is 0.0074 times 40 is 0.296. R1 will be the same. So 0.296 plus 0.296 over 4 is 0.15 ohms. For R1, R2, 0.012 is the value of R2. And that times 40 is 0.48. I didn't actually type that in, but that is it. And 0.296 from before. And that gives us 0.19. So there's our R1, Rn. There's our R1, R2. 10. State the information and the precautions to be taken prior to conducting an insulation resistance test within an insulation. Within an insulation? I think that means within an installation. Okay? Yeah. Bear in mind I'm also doing 18th edition content right now and I'm knackered. Explain might be necessary to subdivide a large electrical installation when conducting insulation resistance tests, then state the values of test voltage required. Alright, so the information precautions to be taken, I can go through that, but you've heard it again and again, but it's actually there in the guidance notes 3. So the information to take is any sensitive equipment, and the actions to be taken will be to remove the sensitive equipment. Okay? The information and precautions. Alright? The information is what sensitive equipment is there. The precautions are let's take them away from the test, or provide limitations on that. It may be necessary to subdivide it. I couldn't find a specific bit of text that covered this in guidance notes 3 or anything, but it's a common understanding with the this is why on your testing courses we do that parallel thing, 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3, to get us to understand that if we put many circuits under an insulation resistance test, we're going to have a lower value due to the additional parallels along the run of the circuit. The longer the cable, the more the actual parallels are within the cable between the two conductors, and technically then the longer the cable is, the lower its insulation resistance because of the parallels within it. Now if I go to a supply and I go on the main supply intake and I have a distribution board, the requirement of the regulation, if you actually look in well, chapter 61, but it'll be chapter 64 soon, it actually, it tells you that the insulation resistance test will be carried out at the board, with the board isolated. So I go to that board, I turn the supply off, and I have that board. And if that board feeds another board, I turn those boards off, and I just test that board itself, and then I'll do the test again for that board. If I have all circuits on, and then they go to another board with all those circuits on, all these parallels are going to start creating parallel resistances, and my value of insulation resistance will become affected, and I'll get an inaccurate reading. So we had to subdivide it to avoid false readings that can be created by the numerous parallels from further distribution. Responses like that would be perfect. But that's the idea. You're removing the additional parallels created by further distribution and final circuits. C. State the values of test voltage required and minimum acceptable values of insulation resistance for each of the following. You can just take that from the table in the guidance notes, really. Domestic ring final circuit, a 230 volt circuit, 500 volts DC. Industrial ring at 75. Industrial control circuit at 750. Okay, what's above 500 volts? We'll go to 1000 volts. Extra low voltage. Well, that's self-impelled. We'll go down to 250. But do remember to state DC with those as well. All right. That's question 10, I think, done. I don't know how long that's taken to fly through. Probably best part of 45 minutes or so. But remember, that's a 3-hour. It's a 3-hour paper. All right. Familiarity with reference material is great. Some of the questions, though, as you go through that, you should really just know, and you shouldn't really need to go and reference them. As I say, I used the 3 hours fully. Not so much because I was looking for the answers, but more because I was trying to better present the answers, really. I sound like a bit of an idiot now, a bit of a snob. But yeah, go with your instinct on the questions and stuff, but, use the reference material. It's an open book. Take the resources with you. Take the regulations. Take the building regulations. It's absolutely it's absolutely fine. Right, we're done with this one. What I'm gonna do is I'm gonna start putting in some content to create to help support the model project that I've also created. But I'm also right now working on the 18th edition content. Haven't decided how best to present that, because I might put some free content on actually, because there's a lot of people who are confusing things with the 18th edition. So I might just put some free content out there in the next few weeks. We'll see. But yeah, hope this has helped. I've gone through it nice and quick because you could pause it and you can find information. It's just more, this isn't really showing you how I answer questions. It's showing you how I navigate, really, and I navigate a response. But if you want any further advice on anything or questions or me to go through things more detailed, then add a comment, and I'll respond when I get some time, and I will do the best I can for you. Alright guys, yeah, bye.